So 4C will now cover a mixture of everything you've done in 4A and 4B, just for applications. Right? And there's also one more thing you'll be learning in here called angles of elevation and depression. Okay? Now you'll remember in the previous questions, here we saw this word called the horizontal. Okay? Now that's going to have something to do with what we'll be doing in the next part. Okay? So just remember, horizontal just means that way. Okay, that's your horizontal, and that's vertical. Okay? Just common knowledge that you should know. But we're going to learn how to apply what we've learned in 4A and 4B to find angles and also to find lengths. Okay? So our intention is to find angles and lengths within the problems, like I said. And then we're going to understand, as a success criteria, understanding what angles of elevation means and angles of depression. Okay? And to be able to draw, okay, and a lot of the times you'll need to be able to draw your diagrams for these questions, right? Because it's a lot harder to actually visualize something in your head as opposed to just seeing it right in front of you. Okay, so it's always a good idea to draw these questions. And again, we're just working with right angle triangle questions, all right? And we're also going to know how to apply the correct trig ratio to solve your problem. So again, whether you're using normal trig or inverse trig or Pythagoras, okay, you'll be using either of those to find certain lengths and angles. All right, so just a bit of a recap. Remember, rearranging, we need to know how to do that. And we need to remember our inverse operation. So the opposite of plus is minus, minus is plus, times becomes divide, divide becomes times. Okay? Whenever you're trying to solve certain questions. Also, you'll remember, I'm going to quickly go back. Let's see, 4A, just these. Remember when we learned these things? So when you get a question, for example, that's like this, or it's like sine 45 equals x over 2, so if the unknown's on top, just get that 2 on the bottom, bring it to the other side, it becomes times, because it's divide here. But if your unknown is on the bottom, like this, all you got to do is just swap them. Okay, so the unknown goes on the left, that number goes on the right, and you're left with this guy. That, and then you evaluate it. Okay, so just keep in mind how we rearrange equations to solve them. And we were up to 4C. Alright, so rearranging, really important. Okay, just remember how to do it. Right, so angles of elevation and depression. This has nothing to do with your mood, okay? Not with your mood, but referring to how angles work depending on a certain reference point. And when I say reference point, so if your starting point is here, like here, let's say there, no, Tonio is not showing his biceps, all right? He doesn't have any. But there is my horizontal. The angle there, basically, think of it as 0, starting point. Elevation means you're going above the 0. Depression means you're going below the 0. Okay? So think of angles of elevation and depression as either going above, so that's elevation. Depression would be going below. Okay? We use them. Okay? The reason why we have these is because you're sometimes wanting to look at something either above or below your reference point. So if you have your horizontal line, let's see, for example, if I'm like, actually I'll just stay here. I'll stand here. So if my horizontal line, because I'm so short, is right there, if I am looking at the projector, that is elevation. I'm looking above my horizontal. Okay? If I'm looking at Nazmi's shoes, that would be depression, because I'm looking below, okay, my horizontal. Alright, so it's where you use it when you're trying to refer to looking at an object from a certain reference point, so starting point. An angle is formed between the horizontal line and the line of sight. Okay, so if I'm here and this is my horizontal and I look above me, okay, you can see that it forms some sort of triangle and there's an angle between my horizontal and what I'm looking at. Okay, so the idea is you're trying to calculate what that angle is. And that's what that's all saying. So here's an example. Let's say you're at a This is you. You're a giant. For some reason, you're as tall as a lighthouse. Okay. If you have a horizontal there and you see a boat down at the bottom, okay. If you're here and you see the boat and you're looking down, okay. There's your horizontal and you look down. That's an angle of depression right here. Angle of depression right there because you're looking down at the horizontal. However, if you're at the boat, okay, and you're over here, and you look, here's your horizontal, and you're looking up, okay, that's an angle of elevation. That's what that would be. Okay, so depending again on where you're observing from. So similar here again, I kind of went backwards, but here, okay, if you're the lighthouse and you look down, here is an angle of depression because there's your horizontal, okay, and you're looking down at an object, okay. But again, if you're here and you're looking up, there's your horizontal, it's elevation. So just understand, elevation means looking down. Depression is going down, elevation is looking up. Also, a couple things to note is with these questions, let me just make a point of this, is that you'll find when you're looking at the angles, these angles here, they're all right angles. You see that? All of them. So they'll always equal 90 degrees. So let's say, for example, here, my angle, which is another color, angle of depression here is like, let's go 49 degrees. Okay? What would this angle be? Anyone know? So if it all equals 90, that's 49. What should this angle be? 31. Good. So that's 31 degrees because it should always equal 90. Okay, so just keep that in mind with these sort of questions. They'll definitely come up where you need to figure out, well, if that's that angle, then what's the rest of it in a bit. One more thing, and I know you hate this. This angle here, you'll notice is this 49 is actually the same as this. They're alternate angles. Okay, alternates. Just keep that in mind too. Okay, you'll come across them. Alright, so as I said, for example, you're at the top of the cliff right there. Okay, you're looking down. So there's your reference point, horizontal. Okay, you're looking there and then you look down. So that makes an angle of elevation of 34 degrees. Okay, and again, like I said, what you'll notice is that angle is the same as this angle here. So if you think about it, angle of depression and angle of elevation, they're actually the same depending on what part you're looking at. Okay, so if you're up here, this angle, 34 degrees, is the same as if you were down here and you're looking up. Okay, they're actually exactly the same. Alright, so keep that in mind with these questions. There's angles here that you'll need to find where it's like, oh, what is this angle? Okay, well, if you actually, the question will be like, this has an angle of elevation of 34. What is that horizontal angle there? Well, if you actually do that, find that, you'll notice that that angle is the same as that. And also, if there was something here, okay, if there was, this angle will be the same as that angle. Okay, all similar, or all the same, sorry. Alright, so let's do some examples here. Alright, so let's go to this page and do these examples. Okay, at a certain time of the day, a light post, which is 5 meters tall, will cast a shadow of 2.2 meters. What is the angle of elevation of the sun at that time? Okay, question here is, what is the angle of elevation here? So what are we looking at? If it's angle of elevation, that means here's my horizontal, I'm looking at the sun like that. Okay, so if you have your diagram here, okay, it's a triangle, I can definitely tell that. Which angle are we looking for in this question? So it's angle of elevation, so you're looking up here. This one here? Yeah. Good, so you're looking for this. If it was angle of depression, okay, then you'd be looking for this, but it's not. Okay, it's angle of elevation. So I'll redraw it again so you can actually see it without all the fuss. Okay, always draw your diagrams, guys, it really helps. Okay, so that's 5 meters. This is 2.2 meters. And I'm just looking for this angle. Okay, easy. Again, if you just draw your diagrams, it really helps it to be a lot more clear. So label it now. So there's your angle. Okay. There's your angle. So there's my opposite. There's my adjacent. Okay, so again, figure out which ratio you're going to use for this. You've got O, you've got A, so you're going to use your tan ratio. Okay, use your tan ratio. So that's going to be tan inverse. My opposite is 5. And my adjacent is 2.2. And just put in your calculator. So tan inverse fraction 5 over 2.2. And enter. So that angle of elevation 66.25. Yes. 66.25 degrees. So that's my angle of elevation. Again, these questions are easy. Just got to read them and draw your diagrams. I know that the next couple examples are not in your books, but if there's space in the back of them, please write them down, okay? Because I don't know, I feel like we needed to include a few more examples. So I just added these a couple minutes ago. So put these in the back of your books. I want you to write them. And these will be good to use. So these examples, they're not in your books. So just do it in the back or somewhere. So write it down in your booklets, please. I'll read it out as you write it. So it says, from a point on the ground, Upton, copy this. Whole question? Yep. From a point on the ground, 12 foot from the base of the flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? Okay, so from a point on the ground, you're at the ground, the angle of elevation, you're looking up, it's 53 degrees to the top of the pole. How tall is this flagpole? Okay, you'll find again, you'll have to draw diagrams for this because it just helps you to visualize what is actually happening. Okay, so drawing the diagrams goes a long way when you do these questions. So write it down. I know there's a lot of words there as well. Okay, but don't fret. Angle of elevation, you know what that is. Okay. But it's also a good idea to maybe even highlight some of these. Okay, not a bad idea. Okay, I'm going to highlight angle of elevation. Sorry. Okay, highlight some of this. So angle of elevation, that's a key word. Top of the pole, there's another key word. Okay, top of the pole and 53 degrees. Okay, and then the question is saying, how tall is this flagpole? So this question is not looking for an angle, you're looking for a length now, aren't you? Okay, so you're not using inverse, you're just using normal tree for these ones. So you have to read the question properly. I also forgot to highlight how long or how far the pole is from the base of the flagpole. Basically highlighted the whole thing, but it's okay. Right? Don't let all the words scare you. And you'll find a lot of the trick questions will be sort of similar to this. Right, I'm going to draw it. So you've got a flagpole. Right, let's draw that. You don't have to be as nice as mine. You can if you want. So there's my flag. There's the top of it. And there's my pole. Okay. So the flagpole, yep, and then from a point on the ground, we don't know what the point is, but I'm just going to draw a point, let's say from this point here. Okay, it's 12 feet, so this is 12 feet long. Okay, the angle of elevation of the top of the pole measures 53 degrees. So if I'm looking down here and I elevate to the top of the pole, so I'm looking at that, it's 53 degrees. Okay, so this length here, okay, this angle here, 53 degrees. Okay, so the question here is, how tall is that flagpole? So what is this length? Okay, if you wanted to, you could redraw it again to take out all the unimportant information, but it looks like this. Okay, so this is 12, this is 53, what is x? Okay, it's that kind of question. Correct. So if you want to, you don't have to be as detailed as me, just go straight to that. Okay, but I know you youngins love drawings. So there's my angle of reference, so that's going to be my opposite. That's my adjacent. There's my hypotenuse. Right. This question, all right, it's looking for a side length, so it's not inverse, just normal trig. So out of the three, so remember if it's just angles, if it's just lengths, it's going to be sine. Oops. Actually, yeah, sorry. Sine of the angle is equal to O over H. It's cos of the angle, A over H. And if it's tan of the angle is equal to O over H. Okay, remember the three normal or basic trig that we use. Alright, so here you've been given A, you're looking for O. So what has O and A? I see that tan has. Alright, so we're going to use the tan formula. So tan of the angle is equal to O over A. That's what this is going to use. Alright, so let's work it out. Tan of the angle, 53 degrees, is equal to the opposite, which is x, the adjacent, which is 12. Okay, remember, inverse operations, when you get a question like this, isolate the x. Get rid of that 12. It's divide here, so over here it becomes times 12. So you're left with x equals tan of 53. Oops. 53 times 12. Right, so put that in a calculator. Tan of 53, bracket, times it by 12, equals 15.92. So the length of the flagpole is 15.92. Straightforward, easy? Alright, we want to do one more example, or are we alright with that? Maybe just one more? We'll do one more, then you guys can do 4C. Alright, so make sure you copied it down already. I'm going to go to the next one. Okay. This one is from your textbook, okay, this example. And the reason why I put this on is because you'll find that you'll get questions like this in your school. Okay. Okay. Again, always draw your questions out, okay, when you do these, because it just helps. There's no point in trying to understand the question or trying to do the question without actually seeing it for yourself. I'll read it here. Two vertical buildings positions 91 meters apart, 136 meters tall and 192 meters tall respectively. Find the angle of elevation from the top to the shorter building, so the top of the shorter building to the top of the taller building to the nearest degree. So you're looking for the angle of elevation. That means elevation, you're looking up. So if you were the smaller building, you'd be looking at the top of the taller building because it's above. This isn't all gibberish. Oh, it's not going to become gibberish eventually. Right. I'll highlight some keywords there that you should use. Two vertical buildings, so 91 meters apart. That's a keyword there. Okay. One of the buildings is 136. Let's use another color for that. One of them is 136. Oops. And the other one is 192. One is 136, the other is 192. Other keywords there. What is the angle of elevation? Okay, I'll underline that one. Okay, elevation, that one there, it's from the top of the shorter to the top of the taller. Okay. So what you should do first here is obviously draw your diagrams. So I'm going to draw two buildings. Let's just say this is my land. Okay. So you've got two buildings, one here. Okay, one building. Okay, and then you've got another building. So you've got two. Not to scale, that's okay. Okay. Now apparently the buildings are 91 meters apart. So let's put that in. This distance here is 91 meters. Okay, so they're 91 meters apart. Keep that in mind. Now, the question here is, we need to find the angle of elevation from the top of the shorter to the top of the taller. So what that's saying is, if I drew a line here, okay, what would this angle of elevation be? So I'm going to make that my reference point. What is this angle of elevation? Okay, keeping in mind that the shorter building, by the way, is 136 meters tall, and the taller building is 192. Okay. Now the interesting thing here is some of the lengths obviously correspond, and also I've accidentally drawn a triangle. Well, not accidentally, but there's a triangle now. Do we all see it? Yeah, it's right there. There's my triangle. It's a right angle triangle. Okay, right there. Alright, so a couple of things I need to figure out is, if I'm trying to find this angle, okay, I need to know at least one length, or two lengths, sorry, because I'm looking for an angle. Okay, can anybody see at least one of the lengths of the triangle? So there's one triangle here. Actually, let me, I won't isolate it, just draw it out. Okay, anybody see one of the lengths for the triangle?
The horizontal is 91.
Good, so at least this guy is 91, so that's 91. Okay, we need to know one more length though. Yes, Michelle?
192 to 4136.
Okay, yeah, and you got that because you need this length here, yeah? So to get that, it's going to be all of this, take away that, so you're left with this, which is 56, okay. So that must mean that this is 56. So just to make it nice and clear, I'll isolate that. So your triangle looks like this. 56, 91, and you're looking for this angle. Easy. Right, nice and easy. So now when you get to that point, just label your triangle. Here's your angle, so that's O, that's A, that's my hypotenuse. Here you've been given, you've got O and you've got A, and you're looking for that angle. So if you're looking for an angle, use the inverse rules. In this case, we're going to use tan inverse. Okay, so remember tan inverse is O over A. So that means that would be tan of O, which is 56, over A, which is 91. And that will give us, let's clarify that. So shift tan of 56 over 91. 30.62. Is that what you said, Michelle? Cool. 30.62 degrees. Oh, was it 61? My bad. Yes, you're correct. 31. Oh, actually, who read that? Or who said that?
It says 31, doesn't it?
Yeah, is that what it says?
Yeah.
On this calculator?
31.
Oh.
Yeah.
I'm so sorry. Okay. one thing we need to include is read the question properly. Okay, what does it say?
What's the nearest degree?
Nearest degree. So if we were to round this to the nearest degree, what would it be?
32.
Good, 32. So we can't neglect that, yeah?
Why would it be 32 when it was?
Yep, so rounding to the nearest
yes.
degree. Yeah, so you've got to round that. So you've got to get rid of the decimals, just to the nearest degree would be 32 in this case. Alright, any questions? I'll stop here now.